Okay, here I'm testing out the PICDIV. It's a PIC microcontroller program that takes an input signal and divides it down to 1 Hertz or thereabouts. And so here's the breadboard with the PICDIV. It's a PIC 12F675. It'll work on some other 8-pin models though. And you can see the LED putting out a 1 pulse per second signal, flashing at 1 pulse per second, or going off. I could wire it in reverse and it'd be on during the pulse. I've got my oscilloscope triggering on that 1 pulse per second, and you can see it's right in phase every time. I've got the waveform generator generating 10 megahertz into the PICDIV and the 1 Hertz out. I'm using an Analog Discovery 2 for this. It's my travel scope. I programmed the PIC with this little, I think it's ArduPIC program, something like that, software that actually installs on an Arduino, and it has a host program, and you use the host program and it'll write a PIC. The 12F675 is actually a does not support low voltage programming. It only works with high voltage, but it doesn't actually need the any current on the high voltage input. It just needs it to be present to tell the chip that it can be programmed, basically. And so this circuit here actually just has a little 12 volt 78L12 regulator, and it takes you can feed in the 12 volt input on here, and the Arduino will actually switch that on at the proper time during the programming. I put 2 sockets on here so I could program like 16 F84s and some other models with the same programmer. I should have used a ZIF socket, but I was in a hurry and this is what I had available. That you can see this this socket is actually it was a larger socket and I just broke it to size. But anyway, it worked. I had to adjust some of the timings in the software for the Arduino to get it to write reliably, but it did write, and as you can see, the PICDIV is working fine. It's assembly language software that gets installed on the PIC, and there's different models, different versions of the software for different clock inputs and outputs. You can some of them have like a 1 kilohertz, 100 hertz, 10 hertz output in addition to the 1 PPS, and other ones have multiple inputs. This one here is the PICDIV 17 that I've used, and it will take 1, 2.5, 5, or 10 megahertz on the input. It's selectable with 2 of the pins. On pin 6 and 7 you can select which frequency you're inputting, and it will always output a 1 pulse per second at, I believe it's 100 milliseconds wide. Yeah, that's what it looks like. So anyway, that's my little PICDIV test circuit. I'm actually doing this for a a frequency counter clock for a client who has a Nixie tube frequency counter, an HP 5326, I believe it is. And this is going to be, he wanted to be able to use either a GPS or an external 10 megahertz input, and so this will allow him to do that. This is where the external 10 megahertz input will go into the PICDIV to create a 1 pulse per second output to feed into the Arduino, which actually handles the clock timing, setting the digits and things like that, advancing at the proper times, that sort of thing. So hopefully this is interesting to someone.